Many of the systems or examples that we're going to be talking about this semester deal with what are called LTI. Now, LTI stands for linear and time invariant. So, what do we mean by linear and time invariant? Well, linear is fairly simple. It's like a linear equation. If you multiply something in the input, multiply the input, the output is amplified by the same amount, or by the same factor. Time invariant means that if you delay the input, will delay the output exactly the same. And so, because of these two properties, then we can say that the system has superposition. And we are going to be using this a lot this semester. And superposition just says if I want to take and analyze a system, I can look at the system one input at a time, or I can look at it as the complete input and I can split things up, and it really gives us a lot of freedom. So let's think about this as, let's say I have a black box. I don't know what's inside this box, but I do know that it's an LTI system. Now I can have one input and another input, and I'm going to have some output. So if I have an input, let's say it's some function x of t, and I have another function y of t, then I should get some combined result with these two. And let's say that I multiply this function by some value a, this function by some value b. We can multiply both of those by some different values. It doesn't have to be the same. And I can, let's put everything in there. Let's take and let's do some time delay in here. And these time delays don't have to be the same. It can be some other different value. And then what I expect to get out of this box is something that is dependent upon these functions. Now let's say that our box gives us some output, we'll call it L, some function, it transforms these inputs. Then using superposition, it basically tells me that my output would look something like A, L, X, function, or x input, t minus t naught plus b L y function of t minus t1, and that's what my output would look like. Now if the x function was 0, then this first part of the output response would be 0, but it would not affect the second part. And similarly, if the y function was 0, then the response to the x function would exist, but the y function part would not exist. Now, we can also represent this in another form, and this is where superposition actually is defined. So we can also look at it as the combined effect of both of those inputs through the system at the same time. So superposition, just write it out here again, just so that I can put an equal sign with it, looks something like this, where you have some output response that works on both inputs, and that's equal to, if I look at each of them separately. And this works because it's an LTI system, a linear time invariant system. Now we can show how to verify whether a system is linear or not. Let's just use what we know is linear, a linear equation. So let's say that our function, L function of t, is equal to a times t. And now, if I want to look at my function L, function, or let's do this. Let's say that our linear function, or our input, x of t, is equal to 3t plus 5, and our y function is equal to 5t minus 3. So now we can put each of these functions into our box here. So we've got L of x of t, and that's going to be L for 3t plus 5, and that's going to be a times 3t plus 5, and then we're going to have 3a AT plus 5A. So that's for our input x of t. Now let's do for y of t. So that's going to be L of 5t minus 3. And that's A times 5t minus 3. And that's going to be 5a t minus 3a. Forgot a bracket here. So now, if I were to look at L, this function L, and I want to do both of these together, you should get the same as adding these two responses together. So let's do that. And there we go. It's a linear system because the addition of these two individual inputs gets us to the total output. So linear time invariant systems are going to be very important. And this idea of superposition, we're going to use this throughout the semester as we analyze different systems. And we might think, well, why would I want to do this? Well, there are times when you may have some difficult, let's say, let me put another pin color here. Let's say that this is a difficult function. And I really don't want to have to analyze this because it's so difficult. But if I can take and add another function that would make it easier, then I can add that function as long as I can separate out its response at the end. As long as there's a way that I can separate that response out, then I can put this easy function in to make it easier problem, put it through the system, and take out the response of the function that made it easier, and then I know what my solution is going to be. And we're going to play with this quite a bit this semester, so it'll be important that you understand how to come up with or how to identify these LTI systems and how you can use them to your benefit.